Okay, we're given a pyramid, a base 10 by 10 square, altitude of 8. So I've sketched that pyramid here. I've also sketched in red a box that would contain the pyramid. Okay, the base of the box is the 10 by 10 square, and the altitude of the box is 8, so the pyramid just fits inside the box. Now, why would I do that? Well, we have this basic principle that you might or might not remember. If you've done the problems, you should have remembered this principle rather than quoting a formula that you're not going to have on the final. I'm not going to give you this formula. I'll give you formulas for the area and volume of a sphere and maybe one or two others that don't have obvious, that can't be reasoned out in an obvious manner. But I'm not going to give you the area of a triangle or parallelogram or rectangle or anything like that. Okay, so, well, anyhow, we have this picture, and you should remember the point that I made in class, and review that if you haven't, if you don't remember it, that the volume of a pyramid, or the volume of anything that comes to a point, is 1/3 the volume of the container that will just barely contain it. Okay, and that's a little bit of a vague statement, but it applies to pyramids and cones. You can contain a cone and a cylinder whose dimensions are the same as that of the cone. You can contain this pyramid in a rectangular box whose dimensions are the same as the pyramid. Then the volume of the pyramid will be 1/3 the volume of that box. Okay, well, the box volume is 800. Now, we can get that using a formula, but it's better to understand what this really means. So we talked in class about, and we demonstrated it using the little cubes and so forth, how you could fill this box with little cubes. How many little cubes would you need? If a cube has dimensions 1 by 1 by 1, and 1 unit on each side, and I've drawn just a little cube here, and it's a little too big. You know, the 1 is a little too big, but I had to draw it big enough to see it. Here's a little cube. Now, how do we start filling this box with cubes? Well, I would systematically, and there are various ways to do it, but I'd build a row, 10 cubes long. Then I'd build another row 10 cubes long, and another one, until I've filled the base. I've covered the base with a set of cubes. How many cubes is it going to take? Well, I'm going to need 10 cubes in each row, and I'm going to need 10 rows to cover the base. So I need 10 rows of 10 to cover the base, and that gives me 1 layer. Now I need 8 such layers to fill the cube, so I need 8 layers of 10 by 10 or 100 cubes. That makes 800 1 by 1 by 1 cubes, and that's a picture of volume for a rectangular box. Of course, that only applies, when you have even dimensions, okay, whole number dimensions. But it serves to show you why the volume can be calculated by the length times the width, okay? Length being how many cubes in a row, the width being how many rows you need for a layer, times the height, which is how many layers. So length times width times depth, 10 times 10 times 8, that should all make sense to you. And this should be part of a whole chunk of understanding. In any case, that box has a volume of 800, so the volume of the pyramid is 1/3 of that, which turns out in this case to be 267.